Hey guys, welcome back. This is Hampshire Chemistry. Mr. Bowers and I are sadly in other places today.
Yep. We're here, but not here.
Yeah, we're watching. Hey, but today we're going to be looking at our pH and pOH calculations. So make sure you have this page out. I believe it should be number 40 in our binder. Hey, we are going to be setting up and collecting this guide tomorrow. So make sure you're working hard today and getting this finished. Boop, boop. So you might not have noticed right off the bat we have a lot of different formulas here, but don't worry, these are not scary. This is just typing into our calculator. We're going to be using these guys today. Let's break down these different equations together. Now, I am going to be writing and going faster than we might normally in class. So when I'm writing, you are writing. Please feel free to pause at any point if you need a second to write things down. That's what the magic of video is for. So we're going to break these down into three sets of different equations. The first set here talks about calculating pH. Now that was something we looked at yesterday, and really this P just stands for power of hydrogen. Okay? And we can find that power of hydrogen by using a log button in our calculator. Or we could convert back and forth between these H pluses. Now we did connect these H pluses to our acids, but the big thing we didn't mention is these weird bracket things. But it's very simply just representing the concentration between these different substances. Okay. So this first set of equations is going to be useful from converting between that pH, that power of hydrogen, to that H plus concentration, that H plus with the brackets. Right. You notice that they are both, this one solves for pH, this one solves for H plus. Okay. Now here we have another setup here. This is called pOH, okay, where pH measures acidity, pOH measures, oh, that's right, I can't hear you. Yes, this measures basicity. Okay? And these equations are able to convert between that pOH, that power of hydroxide, and that OH minus concentration. Okay? So finally, we have one other set of equations, and that is these guys. Okay? These guys are useful because they don't just help you convert between like pH and OH minus concentration. They let you convert between pH and pOH. We're going to see how to use those in just a second. So pH to pOH, or you could use this bottom guy here to convert between your H plus concentration and your OH minus concentration. Okay. So most of the time I like to use this one personally. Okay. These guys here, it's just I have to type in 14 into my calculator rather than 1.0 times 10 to the negative 14th. That's just a hassle. Nobody wants that. Okay. So the simplest way to kind of understand what's happening here is to see how we use these equations in different problems. And that's what this part one is for. Okay. You're going to be solving for the different boxes here and then identifying whether you're looking at an acid or a base. So let's try it out. There are multiple different ways for you to try to go through these problems, and you could basically solve for any of these at any point. Okay, for this first one, I'm just going to go left to right using our different equations. Okay, so this one is trying to find that H plus concentration. So I'm going to go look up and see, hey, we have our equation for H plus, and I have to have the pH, and we know that. So I'm simply going to take 10 to that negative power of our pH, which in this case is 3.78. Okay? So you want to pull out a calculator, and you can use any calculator you want. I've got my graphing calculator here, but I've also got a little simple calculator down here. Both of these guys have power buttons. There's the caret that you can use, or if you want to be fancy, you can hit second log, and that makes a little 10 to the power for you. Okay? I'm going to mainly just be doing it the simple way, and I'm going to be doing 10 to the power of, helps if I turn the calculator on, 10 to the power of negative 3.78. Okay? And I can just go ahead and hit enter in my calculator, and I get a weird number. Okay? Notice we do have scientific notation here. So my answer to this problem, I'm going to keep that in view, is 1.66. I'm going to go ahead and round to that second decimal place. And remember that this E at the end represents that times 10 to the negative 4th power. So this is my H plus concentration. I'm going to make sure that I'm going to put a molarity for that concentration. Okay? Now, to find pOH, okay, I would look for an equation that lets me convert between these two, and that's going to be my friend up here. Very simply, pH plus pOH equals 14. So if I wanted to find just my pOH, I would just subtract my pH from both sides. So my work for this row is going to be very simple. I'm going to take 14 minus the pH. Okay, so that 3.78. And again, typing into the calculator, 14 minus 3.78 gives me 10.22 as my answer for that first column. Okay. pH and pOH, notice, don't have any units because we're using, these are representing a power of something, not an actual amount. Okay. So finally, I'm going to set up and find my OH minus concentration. Okay. So looking for an equation, bada boom. This guy has my OH minus concentration. I need to take 10 to the negative pOH, which we just found. So let's finish off this row by taking 10 to the power of negative 10.22. Right, this is going to be a weird number, but let's take a look. 10 to the power of negative 10.22. And I get 6.02 times 10 to the negative 11th as my final answer. Hey, that's 6.02. Actually, 6.03 if we round. Negative 11th. Alrighty. So last line here, acid or base. Well, you could use any of these, but I recommend going back to pH. That pH is less than 7, so I would identify this column as an acid. So, lots of talking. Again, feel free to pause, rewind, go back and see how we set up any of these guys. But for right now, we're going to do one more row, then look at one in the back, and then you guys will have some time to work. But I'm done talking here. I feel like we should tag team in here. What do you think, Mr. Bowers?
Yeah, sounds good.
All right, he gave us one moment here, guys. I miss you.
That was weird. All right, so we're going to go ahead and hop on down to the next row here, this 3.89 times 10 to the negative 4. Now I missed it a little bit if Mr. Bartlett talked about this, but remember you guys have the E button on your calculator that we can easily represent these scientific notation numbers in it. In addition to that, remember what we're going to be using later are real acids, right? And I know this isn't showing up too well, but there's different concentrations to acids. And the more concentrated your acid is, it's going to affect the concentration, the molarity of your hydrogen ions, those protons that are very unstable and want to react with things. All right, so here I have the concentration, the molarity of hydrogen ions. What equation should I use? What can I find about this particular substance? Oh, man. So if I look at my equation, I have an H plus. I see there's H plus here. There's an H plus here. I could use either of those equations, I guess, but I don't know. All right, for sake of time, we're going to go ahead and use this pH equation, right? Because that's what I'm looking for. So I'm going to go ahead and type in my calculator negative log of that number. Calculators do a pretty nice job of giving me my parentheses already. Can you guys see that? Are you good with the equations? You have them in front of you. I'm going to go ahead and zoom in. Maybe. Zoom.
Zooming action.
All right. Okay, so I'm going to type that in my calculator. So I'm going to literally type in what I wrote down. Negative log 3.89. I'm going to use the fancy E key. See what I did there? And hit enter. Now, if you do not have a fancy graphing calculator, that's all right. Let's try it on a TI-30. This is my jam right here, TI-30. So I'm going to type in negative it's going to hit the negative button. The log button is right under the 2, the second. Log, same thing. 3.89 e negative 4, end parentheses, and hit enter. Just because this calculator costs $100 more doesn't matter. Look, got the same answer. Understand where your log button is. Fancy thing about it, the log button is connected to the 10 to the button. It's almost like it was designed for these pH problems, right? Negative log button and the 10 to the button, they're usually the same button. Pretty neat. Anyways, I got 3.41. That's a pH. Already, right now, look what I can do with that. What is that? Is that an acid or a base? It's less than 7. That's right, folks. We got another acid. All right, I'm going to zoom up a little bit. Okay, so I have a pH number. I can really go between these two. We saw that with the blue equations. We're good there. I'm going to look up here. Look at how pH and pOH are related to each other. They need to equal 14. So again, if I take, we'll go hot pink like Mr. Bartlett has here. So if I have 14 minus 3.41, solving for pOH up here, I'm able to get my answer. And what is that? 10.59, I think is what I got. And again, like what Mr. Bartlett did here, because I now have pOH, I can simply go purple. Because I have pOH, I don't need to use this equation. I need to find my hydroxide ion concentration. I have my pOH. I'm just going to type it in my calculator. Now there are a couple ways of doing that. You might use the caret button. You might use the button attached to log. You're going to end up getting the same answer either way you do it. Know how to use your calculator and be successful with what you would normally do. So I'll do 10 caret because I like carrots. Baby carrots are not as good as the regular ones. You get 2.57 times 10 to the negative 11. Remember, that is in concentration. That is molarity concentration. All right, that is a very small molarity, right? 0.00000. That's a lot of zeros. All right, you guys good with that? So for right now, we're going to go ahead and skip to the back, but these are what you guys should focus on after this video. Make sure you are comfortable. Make sure you are confident with your calculator. I hope that as I was typing things on my calculator, you checked and made sure that you could do the same thing on your calculator. All right, on to the back. We're just going to do one of these. What's your favorite number, guys? What's that? Oh, 4? Okay, let's do number 4. 4 sounds good. All right, so I have a nitric acid solution. I am given a concentration of it. It's kind of, is that blurry, Mr. Bartlett? What do you think? I don't know. Is it too white? Whitewashed. All right, so I have that concentration. The question is asking what is the pH and what is the hydroxide ion concentration. So again, I'm using those problems from the front, those equations from the front, to calculate different things. I have the concentration of H pluses. Because I have the concentration of H pluses, I can use this equation to find my pH. Back to the back. All right, so what was that? 10 to the or negative? Well, man. So good thing for you guys, you don't have to memorize these equations, but you do need to know how to use them. It's negative log of that number, 0.15. Type it in your calculator. Calculator. Log, man, negative log of 0.15 equals 0.82. 0.82. That is your pH. pH doesn't have a unit. Cool. Remember, it's power of hydrogen. What is the pH? All right, did it. What is the OH concentration? Back to the front. If I look at the front, there is pH plus PO. All right, so I'm looking for the OH concentration. I could go a bunch of different ways. I could either use this equation because I know my H plus. Some people think this is a scary equation. That's okay. So I could use this equation and get my answer. Feel free to do it right now. Or I could do a two-step problem. I could, because I have my pH, I could find my pOH. Then I could hop over here and do 10 to the negative pOH. So you see how all these equations are really interrelated to each other. I'm lazy, so I'm going to do this equation, which is not scary at all. You just type buttons on your calculator and hit enter. So if I'm solving for OH and I know my H plus, I'm going to end up dividing 1.0 times 10 to the negative 14 by that 0.15 from the front. Or sorry, from the question number 4. All right. So my hydroxide ion concentration equals 1.0 times 10 to the negative 14 divided by 0.15. Does that work? I don't know. Does that work, Mr. Bartlett? Creepy.
I know, it's weird.
It's scary. I'm going to use the E button because when I use the E button, it automatically puts things in parentheses for me, and I'm using technology the way technology should be used. I hit enter. Oh, I never like writing that number down, but I will. 6.67 times 10 to the negative 14, and that is molarity. Wait, was that the right answer? Oh yeah, look at that. Bingo. That's all we got for today. I think you guys should be able to be successful in the rest of this. If you do have any questions, we will quickly revisit it tomorrow. Yeah. Be sure to subscribe.
Yeah. Thank you guys so much.